Okay, welcome back to another video on the Maths channel. It's your teacher Mr. Lim here, and in this video we're going to be looking at congruent triangles. So by the end of this lesson you'll be able to define congruence, identify whether two triangles are congruent or not by using the 4 tests, and formally prove that two triangles are congruent. So what is congruence? Congruent means identical, okay, or exactly the same. That means that congruent triangles are triangles that are the same shape and the same size. They look exactly the same. The congruent symbol is 3 horizontal lines. It's like an equal sign, except that there are 3 lines. So I like to think of it as they are absolutely equal to each other. For example, here we say triangle ABC is congruent to triangle DEF. Now the order of the letters is very important. In this example, we started with A, so we need to start with D in the other triangle because they are the corresponding vertex. Then we went to B with a dot, which is E, and last of all, C, which is F, which corresponds with F. Okay, so let's have a look at the 4 tests to prove whether two triangles are congruent or not. The first test is corresponding sides are equal, or SSS, side, side, side. That means this one corresponds with that one, this one matches with that, and this corresponds with that one. So we've got 3 pairs of corresponding sides. The second one is side, angle, side. And it's important for you to remember that the angle is in between the 2 sides. So here we have an angle that's in between sides 1 and 2. Here we have an angle that's in between sides 1 and 2. And that's why these 2 triangles are congruent, side, angle, side. The third one is 2 angles and any corresponding side are equal. This is AAS. So this angle corresponds with this one, they both have X. This angle corresponds with that one, they both have a dot. And this side corresponds with that one, they both have 2 lines. So it's angle, angle, side. And the last one is RHS. A right angle, the hypotenuse, and one other pair of corresponding sides are equal. So here we have a right angle, we have the hypotenuse, and we have a pair of sides. So let's have a look at some examples. I'm going to get you to pause this video, have a go with these questions yourselves, and once you're ready to check your answers, continue playing the video. Okay, so the first one is SAS, side, angle, side. Second one is RHS. Third one is AAS. Fourth is SSS, 5th one is AAS, and the last one is SAS. So just have a look at question E and F. This might be put in the test to trick you, so just be a little bit careful. Just because it has a right angle doesn't mean it's RHS, because here the hypotenuse is not given. We're not told how long it is or that they are equal to each other. Same with question F. There's no lines going through it, or it doesn't say 4 centimeters and 4 centimeters. There's nothing to indicate that those 2 hypotenuses are equal in length. So it's not RHS. Okay. Because congruent means exactly the same, have a go with question A and B and see if we can work out the values of the pronumerals. Okay, so here we have x is equal to 5, and we have y is equal to 7. Here a is between 2 and 3, so the one between 2 and 3 is 25 degrees, therefore a is equal to 25 degrees. Well, if this is equal to 25 degrees, by angle sum of a triangle, b has to equal to 180 minus 125, which is 55 degrees. Right, and on to the final part of this video, how to formally prove that two triangles are congruent. So to prove two triangles are congruent, we need to be able to state that a combination of corresponding sides and or angles are equal according to the four tests: SSS, SAS, AAS, and RHS. Once we have established the combination of corresponding sides and or angles that are equal, we can write a concluding congruent statement and the appropriate test. For example, therefore triangle ABC is congruent to triangle DEF AAS. Okay, so that's the congruent statement. So here we have a question. Prove that triangle ABC is congruent to triangle ADC. So we need 5 lines. In the first line we say in triangle ABC and triangle ADC. Then we need 3 lines of evidence. So we can see here that angle ABC is equal to angle ADC, and that's because it's given to us. It says that they are both right angles. We see that side AB is equal to side AD because that's given to us with the 2 lines in each. And we can also see that side AC is common. Both triangles share that side. So we have a look here. We've got a side, we have a right angle, we have a hypotenuse, and we have a side. So we can now say, therefore, triangle ABC is congruent to triangle ADC RHS. Alright. I'll get you to pause the video, have a go with question A yourselves, and when you're ready to check your answer, I'll get you to continue playing the video. Okay, so in question A, we start off with in triangle ABC and triangle EDC. We can see that AC is equal to EC, that's given to us. We can also see that BC is equal to DC, that's also given to us. And we can also see that angle BCA is equal to angle DCE. So these two angles are equal to each other because vertically opposite angles are equal. Now that we've done our 3 lines of evidence, 1, 2, 3, we can say, therefore, triangle ABC is congruent to triangle EDC, and that is SAS, side angle side. So have a look. Side angle side, the angles in between the 2 sides, side angle side. Alright, question B. Now that we've proven that these 2 triangles are congruent, we can actually prove that AB is parallel to DE. So we want to prove that these 2 sides are parallel to each other, or these 2 lines are parallel. We can say angle, we can say that these 2 are equal to each other because they correspond to each other. So angle ABC is equal to angle EDC, and that's because corresponding angles are equal in congruent triangles. What I mean by that is that they match each other. Okay, corresponding means they match, and because they are equal to each other, we can say therefore AB has to be parallel to DE because alternate angles are equal on parallel lines. I'll get you to pause the video and have a go with these last two questions, and when you're ready you can continue playing the video. Okay, so here we're going to have in triangle ABO and triangle CBO. We have AB is equal to BC, that's given. By the way, this does not have to correspond with this one, okay, because those two sides are equal. We can say AB is equal to CB, or we can say AB is equal to BC. They're both the same, but when we're talking about the congruent statement, the order matters then. So AB is equal to BC. We can also see that BO is common. And we can also see that OA is equal to OC because in a circle, radii are equal. Therefore, triangle ABO is congruent to triangle CBO. SSS. Okay, and in the last question, we have in triangle BAD and triangle DCB. BD is common. And we can also see that these two angles are equal because alternate angles are equal in parallel lines. So I'm going to write angle ADB is equal to angle CBD. Alternate angles are equal on parallel lines. And we can also see that these two here are equal because they are alternate angles on parallel lines. So angle ABD is equal to angle CDB for the same reason. Because we've got our three pieces of evidence, we can now say, therefore, triangle BAD is congruent to triangle DCB because of AAS. So now you should be able to identify whether two triangles are congruent or not, and to be able to formally prove that two triangles are congruent. And that's it for this video.